Hello all. So this is going to be a supplementary video for the fifth part of our CMP 1002 Object-Oriented Programming course. If you remember, in this week we have covered a couple of things. Start with the pointers to base classes, and then we have underlined a bit of a problem when we are trying to access the main classes pointers via the child's functions. And then we just try to solve this thing with a virtual function when we have given a bit of an example, and then we have said that this is the basis of the whole polymorphism thing that is going on in object-oriented programming. Next, we have given a couple of more detailed examples, and then we have talked about something called abstract base class, a class from which no object can be instantiated. We said that if one of the functions of the class is a pure virtual function, then the class is called an abstract base class, and no objects can be instantiated from such a class. And there's a little bit of a syntax related to this pure virtual function, different than the non-pure virtual function. Here I will be talking about a more detailed example, an example about a naval combat simulator. So there's going to be some ships, and the ships will be able to move around, and they should be able to hit each other and try to sink them, something like that. So we will be talking about we will be using the constructors, we will be using the virtual, we will be using pointers to classes, things like that. All of the things, object-oriented things that we have talked about in previous weeks, it's going to be boiled down, it's going to be utilized in this medium-sized code, let's say. So in the slide, it just gives the general idea about what's going to be this naval combat simulator program. So basically, there's going to be three classes. The base class will be what I would be calling a naval ship. It's going to represent a generic naval ship, anything. It could be from a very simple boat to a super big aircraft carrier or battleship, things like that. Anything, but this is going to be the base class. Next, there will be two child classes. One of them I'll be calling the cruiser, and one of them is a submarine. In the main, what I want to do here in this program is, after defining all of these classes and all of their related data structures, local variables, and then functions, I'll be defining one naval object called Black Sea Pirate. So imagine that there's a pirate ship going around in the Black Sea. That is the Karadeniz in Turkish, by the way. And the Turkish Navy, after a while, just fed up with this Black Sea pirate ship, and they just sent one submarine and one cruiser in order to intercept and destroy this ship, because it's just giving a lot of harassment to local regular merchant ships, let's say. So those Turkish ships are going to be represented by one double pointer to naval ship object called Turkish ships. And there's going to be two items that will be recorded in this Turkish ships naval ship array. One of them is going to be a submarine, and another one of them is going to be a cruiser. The submarine BlockRace and the cruiser Barbaros. All right? Okay, let's go to C-line and try to first understand how does this naval ship class works. So as you can see, the naval ship class has a couple of protected variables. The first one is the string name. That's gonna be the name of the ship. Well, simple enough. The next two will be representing that the location of these ships. I'm just again simplifying many things here. So one of the things is gonna be that there's not gonna be a z dimension, so no third dimension, only two-dimensional space. Well, it's simple enough. For the cruiser, I don't think it's gonna be a problem. For the submarine, it could be a problem, but let's not get overboard with many things. Next, there's gonna be the armor rating. This armor rating will represent like when the ship is hit, if the amount of damage that will be dealt to this ship, if it is less than this armor rating, then the ship is unaffected by the attack. If the damage is more than this armor rating, then the actual damage sustained is the damage minus the armor rating. So it's like the protection of the ship, like how hard the hull of the ship is. Next is gonna be the hit point. Hit point is basically the life. If you are more familiar with the games, I think you are very it's very clear what this hit point is doing. If the hit point is 0, then the ship is no longer operational, it is sunk. If it is more than 0, then it's still operational. A two-state, very simple system I'm trying to implement here. And finally, there's going to be a little bool variable. I just don't want to check if hit point is 0 or more than 0 every single time. Checking those kind of things with a little boolean variable is generally much more efficient. And also, it just, as you will be seeing very shortly, the functions will be reading much more clearer if you do something like this is sunk. So, to start with, we will have a default constructor. Nothing very fancy, honestly. The default constructor, obviously, it's gonna be a public function. It will just set the name to nothing. It will set the coordinates of the ship to 0.0, armor rating to 0, hit point 1, and is sunk false. Well, next there's gonna be a regular constructor like this. So it's gonna take 1, 2, 3, 4, 5 parameters. There's name, x, y, armor rating, and hit point. And just put them into their correct places. So name to name, x to chord x, y to chord y, armor rating to armor rating, hit point to hit point. Then I'm not gonna take is sunk as a parameter because it doesn't make any sense. I will just immediately say that this is not sunk yet because it is still operational. I mean, come on. You don't want to make up a ship that is immediately sunk. I mean, you could want to do that, but yeah, let's not do that. Next, there's gonna be a simple function called sail2. This is gonna be how the ship will be moving around in this two-dimensional space. Here, the function will take two parameters, target chord x and target chord y, which is gonna determine the new x position and the y position of the ship after the end of the sailing action. I just want to do a little bit of a checking, saying like if not is sunk, chord x equals target chord y equals target chord y. Representing that if the ship is already sunk, it doesn't make any sense that the ship, it shouldn't be able to sail around. Next, based on this is sunk bool variable, I just want to print out is the ship operational or is it actually like been destroyed. So this function is not going to take any parameters and it's not going to return any parameters, so it's going to be a void function. All it will be doing is, if he's going to check if is sunk is false, and if it is false, then it's going to say the name of the ship followed by is still operational at these coordinates. If it is true, if is sunk is true, then I'm going to say the name of the ship lies at the sea or ocean floor at these coordinates. It's also useful, like the sail function, sail2 function is checking if the ship is sunk, because after sinking you shouldn't be able to move, right? Well, I mean, you can drift with the currents, yeah, but again, simplification. Otherwise this class will never end. Next, I will have a little bit of a calculate distance function. This function will just be taking another coordinate. Well, and then based on this coordinate, based on his own coordinate and this new given coordinate, he's gonna calculate how far away the ship, this naval ship, is to this other ship x, other ship y coordinate, and he's gonna return the distance, just like that. Simple function using the square root, using the power that we have always done with calculating the distances in two-dimensional space. Next, there's gonna be a more sophisticated looking and, well, the longest function in this naval vehicle. Naval vehicle? Am I already? Yeah, I think I'm getting old. Naval ship, okay. You could always say naval vessel, don't get me wrong. Technically, it's still fine, but no. Naval ship. Because it could be a starship, right? Ship is not necessarily supposed to be a naval ship. Huh. Alright. This function called fired upon. So it means like this ship is getting some damage from another source. We don't really care about where the source is. It could be another ship. It could be, let's try to be more generic. It could be some other thing. It could be a plane dropping a bomb. It could be a plane shooting it with a missile, another rocket system, another land-based system. It could be anything. The important thing for our discussion is what is the firepower of this ship, whatever is trying to hit this ship. Again, first of all, I'm just gonna checking if the ship is sunk. If the ship is sunk, then I don't have to do anything else. If the ship is still available, still moving around, if this not is sunk is true, then first of all I'm gonna check if I'm gonna compare if the firepower is greater than armor rating. If the firepower is less than or equal to armor rating, I will go jump to this else, and this is gonna represent that this firepower, whatever that thing is, has no effect on this ship, right? Its armor is so thick, this weapon cannot penetrate the armor and then cannot do any damage at all. It could be like a little, I don't know, you're shooting the ship with a rifle, with a machine gun or pistol, something like that, which is not gonna be able to do any real damage to the ship. Well, it is what is called the small arms, the guns and the rifles. In this case, I'm just gonna say the name of the ship followed by sustained no hull damage, attack ineffective. I just want to specify that this didn't do anything. On the other way around, I'm gonna calculate the actual damage. On the other way around, I mean if the firepower is at least greater than the armor rating. So I'm here. So the first thing I'm gonna do is damage. I'm gonna set up a new local variable called damage. Damage equals firepower minus armor rating. So apparently the firepower is gonna be bigger than the armor rating. Otherwise, it is an ineffective attack, as we have mentioned already. Now I'm just calculating what is the difference. And the difference is gonna be the actual damage that the ship will sustain. Next, after calculating the damage, after checking that this ship is operational, after checking that the firepower is at least greater than armor rating, and calculating the value of the damage, I'm gonna finally check if the damage is greater than the hit point of the ship. Because the ship could be wounded or the damage could be so high that immediately the ship can sink. So if the damage is greater than the hit point, I will set the hit point to 0, I will set the is sunk parameter to true, and then I'm gonna say name of the ship followed by sustained critical hull damage and sunk. Right? Okay. On the other way around, if the damage is less than or equal to the hit point, maybe we have to change it a little bit, right? Because if the damage is greater than or equal to the hit point, then the ship should be sustaining critical damage and then sunk, right? The hit point should be positive. Otherwise, the ship is sunk. If the damage is less than the hit point, then subtract this damage from the hit point. So the ship has taken some damage, but it didn't sink. And afterwards, he's gonna say name of the ship, sustained hull damage of this amount, and the remaining hit points is the hit point value. So specify that, he has this amount of hit points remaining before sinking. Okay, this is again a complicated looking function, but nothing super strange going on here. And the final function of the class is gonna be this virtual function called attack. This is gonna be the function where this ship is attacking another naval ship object. But I intentionally put it as a pointer to a naval ship because I would be giving addresses of the ships from the main. Therefore, he has to take the address of the ship who is being attacked, and because he's gonna do something about it. But I intentionally am leaving this function, this attack function, as a virtual function, because after a while I just want to think like a cruiser, a destroyer, a battleship, an aircraft carrier, a submarine. All of these ships have very different attack patterns. For example, cruiser, destroyer, generally they either shoot a missile or they have a big turret and then they shoot cannons. Well, maybe not cannons, but I'm not very sure about the correct terminology right now. This big guns on the ship, right? Whereas a submarine generally shoots either a missile again or a torpedo. Whereas in our aircraft carrier generally do not have a weapon on its own. What he just does is he's just launched some fighter aircraft or bomber aircraft or fighter bomber aircraft, and then those things actually do the attacking and sinking, and yeah. So this is gonna be a virtual function. All right. Cool. So next, I'm gonna start with my cruiser class. The cruiser will be inheriting the naval ship class. So it's gonna be a child class of the parent class naval ship. So in addition to the naval ship's local parameters, these name, chord X, chord Y, armor, rating, hit point is sunk, he will have a couple of more local variables, more of its own fields. The first one is the firepower, how effective its weapon is, how strong it is. The second one is going to be the range of this weapon. If the distance between the attacker and the attacked ship is bigger than this distance, then he's going to say my effect is ineffective because I couldn't hit it. It's out of my range. Next, there's going to be ammunition. How much bullets, cannons, missiles, whatever you want to call it, items that you have remaining that can really shoot at the attacker. If it is less than 1, then it means you cannot because you're out of ammo. And finally, just to spice things up, I am also putting another variable called hit chance. So this is out of 100. So 85% of the chance apparently the cruiser is able to hit it. Let's oversimplify things, like based on many things, factors, the hit chance of this cruiser while he's attacking is flat rate 85. Yeah. It is again a dumb default constructor that just does nothing. Well, the only thing that it does is calling its superclasses constructor, and actually superclasses default constructor. Next, I will have an actual real looking constructor that takes a lot of these values and calls again the constructor of his parent class, but this time not the default constructor, the classical constructor. Alright, finally I have this attack function. I am overriding this attack function of my parent class. This virtual void attack function is now being overridden in the child class, the cruiser class. So here, this is gonna be simulating how does the naval ship, the cruiser class is attacking its targets. So first of all, as you can see, there are a couple of checks happening here. First of all, if the ammunition is greater than or equal to 0. If it is not greater than or equal to 0, then you should be able to attack it, right? Because you have enough ammunition to do that. But we have to check one more thing. If the target ship is really within my range. So in order to do that, I am actually calling the calculate distance function of this target ship, the naval ship object. I'm just calling that object whose address has been given to me with this target ship pointer. Maybe I should just be calling it instead PTR target ship, I guess. This is because I just want to emphasize the fact that this is a pointer to a ship object, not a ship object itself. So this PTR target ship, the ship that this pointer is pointing towards, we're gonna call its own calculate distance function by taking the chord X and chord Y of this ship, whoever is calling the attack function. He's gonna give his coordinates, the X and Y, and he's gonna give it to the target ship's calculate distance function, and then that function will say a number, will calculate a number. And that number will represent the distance between this ship, the attacker, and the target ship. Then I'm gonna check if this number is less than or equal to the weapon range. Whose weapon range? This class's weapon range. In this scenario, 200. I didn't want to write down 200 because maybe it could be, changeable in the future. That's why I just want to write it as a variable like this. If both of these conditions are true, which means I have enough ammunition, and I am within range of this target, then first of all I'm gonna say target is in range. And then I will decrease my ammunition by 1, because I'm now using 1 ammunition. Then the last part, the last if else, has to do with this hit chance. As you see, I am assigning then hit chance to this cruiser, and every time this cruiser is attacking any ship within its range, and as long as he has enough ammunition, he is just gonna generate a random number. Take the mode of this thing from 0 to 100. Okay, so the outcome of this value, the outcome of rand parentheses %0 is %100, will be a number between 0 and 99. If this is less than or equal to the hit chance of this cruiser, then it means he really hit the target, right? And I just want to notify that I really did hit the target by saying that target hit. And finally, I want to call this ship, this target ship, and I'm just gonna call the target ship's fired upon function, because I just want to inform the other object, the object that has been hit, because this is the attacker, right? There's the other way around. This is the ship who was actually sustaining the damage, sustaining the hit. I'm just gonna call the fired upon function of that ship with the firepower value of my firepower value. If the attack is effective or ineffective, if the ship got sunk, if the target ship got sunk or not, telling about that, giving information about that is gonna be the responsibility of that ship, right? It's not his job, because he doesn't know his armor rating, his hit point. No, he doesn't know that. The attacker doesn't know those things about the target. Only the target object knows about those things. And since we are dealing with object-oriented programming, I just want to keep things wrapped up in a good information hiding sense, right? Cool. On the other way around, if the result is greater than the hit chance, I'm just gonna notify that I didn't even able to hit the target and I missed the target. Target missed. Finally, I'm gonna say if the ammunition is not greater than 0, or the distance is too big for my weapon range, I'm gonna say target is out of range. Oh wait, let's say target is out of range, or attacker is out of ammunition. Cephanem bitti. So this is gonna be a long looking class, right? A long looking function. And it has also the randomization element here, which is gonna make things a bit unpredictable. Alright. Last class, my submarine class. So basically, submarine class is similar to the cruiser class. It is again inheriting the naval ship class. So it has all the functions, all the member variables of the parent class naval ship. Additionally, it has a firepower, it has a weapon range, and it has an ammunition. One thing is different here. I am not putting a hit chance here because since I want to give a different version of the same attack function, I just want to change things a little bit between these two classes. So the crucial main difference is gonna be here is the fact that the cruiser has a chance of missing, whereas I'm just assuming that the submarine is a hidden craft, therefore it just cannot miss. Well, I mean, of course, you can argue about that, but this is for simplification purposes again. It has the default constructor, it has the normal regular constructor, both of them calls the corresponding constructor of their parent classes. And the next thing is my, again, attack function. The attack function is pretty similar to the attack function of the cruiser, with one notable fact. I am not gonna calculate any I'm not gonna make any randomization here. So this element is out, right? Because it's gonna hit the target no matter what. No matter what. So immediately I'm gonna say target hit, and I'm just gonna call the fired upon function of the target object, whatever that thing is. In order to again show like this is in range attacking, I just want to be consistent between the classes. I'm just gonna say target is in range, firing torpedo, not attacking the firing torpedo, well, and then the target hits, again subtracting the ammunition. Again, I'm calling the fired upon function of the ship that has been targeted by this object. And finally, again, if either he runs out of the ammunition or he's too far away, he won't be able to hit it. So it's gonna say target is out of range or attacker is out of ammunition. All right, good. I'm hoping that this is fine so far. I mean, this was a big quote. The important thing here is that the attack function was, as you can see, a virtual function, but not a pure virtual function, which means I would be able to make an object out of the naval ship class. But since this is a virtual function, I can override it in the child functions like this and like this. Because what I'm trying to do is, what I'm trying to achieve is, every child class of the naval ship have their own attacking functions, which can have different functionalities. Like here, this doesn't have a randomization element, whereas the cruiser's attack has a randomization element. He can miss. Alright, let's look at the main. First of all, I'm just going to talk about a bit shorter, easier to grasp version of the yeah, I'm gonna just look at the easier, shorter version. I have a bit of an interesting looking code here, this srand time null. I may have talked about this, I think I have talked about this thing in a couple of times, maybe once. Like when you are using the rand function, there's also a seed of the random number generator. If you don't give him a seed, then he's gonna just replicate it. Like all the time you run the code, he's gonna give you the same result. If you do not set the seed of the random number generator, and you have to set it to a different value every single time. And a very, very simple way of doing it is just getting the time and giving it to the srand function, so that, you know, as you are every single second, every single millisecond, the time changes. Therefore, the result of this time null function changes. Therefore, the input of the srand changes. And consequently, we will have a different randomization results every single time because of this nice little looking code. All right? Good. So let's look at our ship objects. So the first one is super simple, the Black Sea Pirates. It is gonna be a naval ship, because I don't think this is gonna be a cruiser. I don't think this is gonna be a submarine. It is a ship. His name is Korsan 1, Pirate 1. It is located as 200-200. It is a very weak armor with the armor rating of 10 and a hit points of 110. Next, I'm opening up 2 pointers to naval ship objects. Okay, this is interesting. These are pointers to naval ship objects called P Turkish Ship A, P Turkish Ship B. Next, I'm gonna open up 2 variables, 2 objects, Turkish submarine, Turkish cruiser, with their names, BlockRace and Barbaros, have their locations, armor ratings and hit points. Next, I'm gonna take the address of the Turkish submarine and put it inside the P Turkish ship A, and do the same thing for the Turkish cruiser object. Take its address and put it inside the P Turkish ship B. So if you are remembering from this course, I am able to do that. What am I doing? The thing that is kind of interesting is the fact that Turkish submarine, that object, has a type of submarine, and Turkish cruiser has a type of cruiser. Whereas the P Turkish ship A and P Turkish ship B, both of them are pointers to the superclass, the naval ship. However, I can, as I mentioned, I can take the address of any any object derived from the child class of the parent class, and just assign its address to the pointer of the superclass. Next, and finally, I'm just gonna call the attack function of the ship A, then ship B, then ship A again, and I'm just gonna give the address of the Black Sea Pirate object to the attack function. Otherwise, he won't be able to change the value of the Black Sea Pirate object. Why? Because of the call by reference, call by value concept here. If I only did send the Black Sea Pirate object as is, he will be making a copy of the Black Sea Pirate object within the attack function, and he will only making the changes with for that copy. But if I just give him the address of the my local variable, then everything is fine and dandy. So let me run this function. Let me run this main and see actually what is happening here. Okay, so BlockRace. What was the BlockRace? Submarine. So the first one is attacking ship A, which is a submarine. The ship A is attacking. Okay, what's his damage? What's his firepower rating? 100. His firepower is 100. Okay, and he has the other ship, naval ship, has an armor rating of 10. So 100 minus 10 is 90. So the ship, the Black Sea Pirate ship object, got hit by a damage of 90. How am I doing that? How am I calculating that? Here I am going to do attack function. Attack function of which class? Submarine class. Because P Turkish ship A is an pointer referring to a Turkish submarine object. So when I see this attack function with this Black Sea Pirate, the address of the Black Sea Pirate object, I'm just going to attack function of the submarine class. This one, yeah. So he will check if the ammunition is greater than 0. Yes, it is, because I just set it to be. Wait, where did I set the ammunition? Oh, I initially set the ammunition always to 50. So 50 is bigger than 0, fine. This distance, my distance is what? 120, 200. What is the distance of the Black Sea Pirate? 200 by 200. Therefore, the distance is around, not around, 80, I think just 80. And what's the range of the submarine? Range, oh, there's no range. Where did I put the range? Oh, sorry. I'm sleeping today, apparently. There's a range of 100. So 80 is less than or equal to 100. So he's able to hit the guy. Where's the attack function? Yep. He's here. And he's going to say, target is in range, firing torpedo. And decrease the ammunition by 1. Target is in range, torpedo. Then, I call the fired upon function of the target ship with the firepower of what? 100. So fired upon function. Am I sunk as the Black Sea Pirate? No. Is the firepower 90 greater than my armor rating 10? Yes, it is. Then the damage is 90 minus 10, 80. Wait, the firepower was not 90, or was it? fire was 100, sorry. 100 is greater than 10, yes. Damage equals 100 minus 10, 90. 90 is greater than or equal to hit point, no, because the hit point was, where was it? 110. So 90 is not bigger than 110. All he has to do is subtract that value 90 from the hit point and set it to be the next value of hit point. So he's now down to 20 hit points. And then you just print it out by saying name of the ship, Corsan 1, sustained hull damage of 90, remaining hit points 110 minus 20 minus 90, 20. Okay. Here, when I call the attack function, that is what it is. He just says I fired the torpedo, and the torpedo hit it because it is within the range and I have ammunition. Then the guy sustained damage of 90 and remaining hit points is 20. Next, this time the cruiser is attacking. The cruiser attack has one major difference here. The only thing is the random number generation. Apparently the random number, I cannot directly see the random number value. It did really turn out to be less than or equal to 85. Therefore, it did turn out to be less than or equal to the hit chance, which is 85. Therefore, my other ship, the cruiser, also able to hit the pirate ship. So this time, he's gonna say target is in range, attacking, but this time Barbaros is attacking. The cruiser is attacking. And target is in range. Target hits because of the randomization. Then Corsan 1 just checks if he is now, when he takes damage. Let's look at the fired upon function. Am I sunk? No. If the firepower are greater than armor rating, yes. 90 is greater than 20. Yes. So, I'm sorry, no. I immediately go down here and I'm just gonna say, oh, no. Wait a second. Firepower is greater than armor rating, so it's an effective attack. What's the damage? Damage equals 100 minus 20, so this is 80. 80 is greater than equals to hit point, which is the remaining 20. Yes, it is. Then I'm just saying hit point is 0, is sunk is true, and the name of the ship sustained critical hull damage and sunk. The ship sustained critical hull damage and sunk. Finally, I'm attacking the ship for a third time. But I know that the ship is killed already, but I'm just still able to attack it. I attack it, but, well, since the fired upon function, he's just checking if not is sunk. If it is sunk, he's not gonna do anything about it. Right? He didn't say anything. The Corsan 1 didn't say anything in the output. Only the BlockRace is saying it is in range, and it got hit when I actually fired at him. Right? Okay. I know it could be a bit difficult to follow, but you will have the code. I think you do already have the code in its learning's resources part. The lecture course. Okay. So this is a good flexibility. And then, as you can see here in lines number 139, 40, and 41, you see that I really don't care on the left-hand side if this is a cruiser object, submarine object, or if it's even a naval ship object, but naval ship object won't be able to attack. I mean, because his own attack function is completely empty. His own attack action is completely empty, but regardless, this is gonna be a valid function. But let's try to go one more step and try to do this thing. Oh, I just want to run it one more time or a couple of times. I just want to see like our cruiser is missing sometimes. Apparently he's not missing. Damn it. Am I really sure that the S-strand is working? Maybe I'm not quite sure if S-strand is working. Oh yes, it is working. Yeah, you see, this time he really just missed, because the outcome of the randomization is now greater than 85. Therefore, it is really a miss. So for the next part, I will just be doing the same thing, but with a different way of writing and with a different way of data structure. So behold, a two-dimensional pointer to a naval ship object. Haha. Okay, this is a bit strange looking, right? Like this is a two-dimensional pointer. There is a star, and it just seems like new naval ship star 2. So if you remember, the outcome of the new operator is an address, right? Address of what? Address of an array, because this is an array, and when I say new, he just opens up that array and then gives me the address of that array. Each element on itself, each element of the Turkish ships 0, Turkish ships 1, is by itself is a pointer, which is able to keep the address of another either naval ship object, cruiser object, or submarine object. Therefore, instead of just writing down like this and then taking the address and assigning it to different pointers, I'm just saying like Turkish ship 0 equals new submarine blah 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 and the constructor, and Turkish ship 1 equals new cruiser with its own arguments, initialization arguments. So as you can see, I'm not dealing with a single pointer now. I'm just dealing with an array of pointers. But then I will be able to write down things like this: Turkish ships .0 attack the Black Sea pirates. Turkish ships 1 also attacks in this, for the second time, and then the 0th ship attacks in the third round. Let me run this to show you that really there is nothing problematic going on here. Again, run a couple of times until the cruiser misses. Yeah, I just want to underline the fact that really S-Strand is working. So here we have used a parent-child relationship. We have defined a virtual function and overridden it in the two classes. One more very important thing that we are doing here is I'm just taking the address of an object and passing it to another class's object. And since this is attack & Black Sea Pirates, and the Black Sea Pirate is a naval ship, actually I can even attack this one. No? Why I cannot do that? What about this? This I can do. Why? Because Turkish ship 1 is already keeping an address. If I put an ampersand here, it means I'm taking the address of an address, which I'm not intending to do. So this is also valid, as you can see. Because the target ship, what's the type of the target ship? Naval ship. But I can always use a subclass of the naval ship. Let me run it for one more time. So you can play around, honestly, with very different kinds of objects here, shooting at each other. You can also let them move so that they cannot, before these two attacks, let's say Black Sea Pirate dot sail to 400. Now they won't be able to hit it because he just escaped, right? You see, the first one, he just got hit, sustained hull damage of 90 and remaining points is 20. But then since the guy just escaped, fled, he's now very far away. So both of the ships are saying like the target is out of range or attacker is out of ammunition. And the important, there's a little thing that we have done in the attack. If it is in range, then I'm decreasing the ammunition. If it is not in range, I am not decreasing my ammunition, because why should I decrease my ammunition if I'm not actually shooting at the target? I'm not actually shooting, yeah. And maybe if I go back here, let's check it out if this is in range. Still not in range. How about this? Not in range. Okay, this is now in range. So it's like the cruiser attacked it, then he got away. Then the submarine. Oh, maybe we can make something very more different here. I can just say Turkish ships 0 is moving around, right? So he's just going closer to the target ship, right? The first time the cruiser was in range, he attacked it. Wait, the submarine attacked it. Then the cruiser attacked it, but between these two attacks, the ship ran away. Then the submarine continued, pursued it, gets closer. So it's the submarine, he cannot see that, let's assume it. And then he attacked it again, and then the ship got hit and sunk. And that terror, that Black Sea pirate is now at the bottom of the Black Sea, sleeping with the fishes, as the saying goes from the Godfather movies. Okay, this was it for this week's supplementary material. I hope you enjoyed it. I hope this is a bit of an additional exercise, adding some value. So hope to see you next time. Bye bye.